Bismillahirrahmanirrahim. This video is from Fourier series, chapter number 17. And here we'll be solving end chapter question 17.41 from Mr. Alexander and Sadiku's book. And this is on the request of a student. I had earlier also made this video, but there was a mistake. So while we go on, I'll let you know what was the mistake. Okay, the question says that this is the input. It's a full wave rectified sinusoidal voltage is applied to the low pass filter here. Now, this signal is will get its equation in mathematical form. And before we go to that, we first of all let's find the time period. So the time period T is equal to pi 0 to pi. One time period, omega naught we know is 2 pi f or 2 pi over t, so it will be 2 pi divided by pi, it will be 2, and omega n is n omega naught, so it will be 2n. Now we go into the table 17.3, which defines this signal in terms of Fourier series. Now, the only difference between this signal and our signal is the amplitude. Here it is A, here it is 1. So we replace A by 1. And then there are two parts of the signal. This part does not have any time component, so this is the DC element. And this has time component, so this is AC element. So we'll deal them in two parts. So in our case now, you see A we have replaced by 1. So this will become the input signal. First we'll treat the DC. So this is the input DC, and we'll apply this to the circuit. And when we apply a DC to the circuit, we know that the inductor behaves like a short circuit, and the capacitor behaves like an open circuit. So whatever is the input here, that will go direct to the output in this circuit. So we can say that our output DC will be also 2 over pi. So V out DC is 2 over pi. And now we take the AC part, and I hope you remember that to solve anything in sinusoidal signals question, it is easier if we convert the circuit and the signal in phasor form. So that is what we'll do in this case as well. So we convert to Henry the inductor by multiplying by j omega n L. And omega n from here is 2n, so it will be j4n. And similarly, the capacitor, we can write 1 over j omega n c, and putting in the values, this will be the value of the capacitor. And now our signal, DC signal, we know that if it is in V cosine omega t form, that is in time domain plus pi, then in phasor domain, we can write the magnitude and the angle. Same here, this whole thing is our magnitude. There is no angle in this, so angle will be 0. So in phasor form, it will be the whole magnitude, angle 0. Now we just take the nth harmonic, so the summation sign will go. We're just taking one harmonic. So this will be our input signal for the nth harmonic. We can rewrite neatly multiplying this, and this sign comes here. So this is a neater form of Vn. And now we apply this signal to the circuit, and we'll solve for the output. So this is the input signal, and you can see these two are in parallel. So we have to solve them in parallel first of all to get the output. So let's call the parallel circuit as impedance Z. So Z is these two in parallel, and solving them in parallel not explain everything, but I have done all these steps, so I hope you can simply follow it. This will be the final answer. So our circuit now becomes this. This is our Z, this is the input. Now by voltage division rule, we can find VOAC. In phasor, we have also written this as a capital. VOAC is V in AC divided by these multiplied by Z. We can also write it by bringing Z on the top and VOAC to the right like this, so it will be easier to solve. And now putting in the value of Z, we are not putting in the value of V in AC just to keep it simple. At the end, we'll put this value. So now taking the LCM here, and then cancelling the two denominated. So this is our slightly simplified form of a signal. Now the error I was talking about, that in the solution manual from this step, he has gone to this step, which is wrong. A student pointed out in my uploaded video that how did you get 8n, whereas from here you can see it will be 8n square. So I checked and I found, yes, there is a mistake in the solution manual, as well as there is a mistake in the end chapter answers given in the book to me. So let's see what I have done, and then maybe you can find out error in my working. So this I have done. I have just multiplied everything from here. Then just rearranging this, j square will be -1, so -1 and minus it will be plus 4n. And 4n, then j terms together. Taking common 2 and the j terms. And now we can cancel 10 and 2. It will be minus j5 2 and j4n square minus 5 v in AC. And now we should put in, okay, from here, first of all, let's see, the denominator is in this form, the complex form, and we know that to divide we have to convert it into polar form, that is the magnitude and angle. And magnitude is nothing but under root x square plus y square. And angle theta is tangent inverse y over s. So we'll exactly follow this. So from here, square of the both, then under root, numerator remains same, and the angle is tangent inverse y over x. And this is v in AC. Now we have plugged in. So we removing the minus sign, minus minus plus, and multiplying by 5, so it will be 20 angle 90. Bottom remains same. Taking the angle up, it will be 20 angle 90 minus this tangent angle, and this remains as it is. Now we need to open this to simplify further. Okay, so opening this bracket, rearranging again. So this is a simplified form. Now what we'll do to write it in a further simplified manner, we assume this whole thing as AN. The magnitude part, we are calling it as capital AN. And the angle part, we'll name it as theta N. So this is theta N. That means our VOAC will be AN, angle theta N from here. AN and theta N. Now the total output will be VODC plus VOAC. VODC was 2 pi and VOAC is AN angle theta n. And from here now, from phasor to time domain, we'll go back. So it will now plug in for all n's, that is the summation sign, an cosine 2 and t angle pi. So this will be our answer. But whenever you write this answer, you have to write this, what is an and what is theta n. So this is how it has been written in the book, but the book answer does not match this part and also the theta part. I hope you have been able to follow. Please let me know if there is a mistake. Thank you. Okay, one more point. This was the circuit, and you can see that the output has a DC component, and DC component implies that this is a low pass filter. It is allowing the low frequency signal or zero frequency signal to pass. That is how, that is proof that this circuit is a low pass signal. Thank you. I had pointed out the error that we noted to Mr. Dr Sadiku, one of the two authors, and this is what I had sent in the mail. And nice of him that he acknowledged the mistake. He said, I have carefully gone over the solution and your solution is correct. Thank you for bringing this to my attention, Matthew.